All right, folks, welcome to Yak Math videos for your stats. Intro to probability quiz review, folks. You heard it here first. We're going to move your quiz to Tuesday the 7th. You're going to get an in-class homework on Monday. It's going to look very similar to this. Wanted to give us a little bit extra practice time for the quiz. So again, start spreading that news. The quiz is now Tuesday the 7th. In class on Monday, you're going to have an in-class homework that looks very similar to this. Anyway, here are the answers. Guys, this is the sample space. Again, you're spinning a spinner with spaces labeled 1 through 4. So all of the sums, you're going to write your sample spaces, all of the distinct sums you can get, okay? Not too bad. Find the probability of getting a sum of 5 or more. So if x is the sum of the two spins, then I want the probability that x is greater than or equal to 5. There are 11 different ways, 11 different outcomes of getting 5 or more in that table. What's the probability of getting a sum that is less than 6? There are also, let's see, there's 10 of those, all right? So 10 different ways of rolling a 5 or less, because to get a sum of 6, that means you're getting 5 or less. We got whole numbers. These are discrete. X is a discrete random variable. Find the expected value for the sum of the two spins, all right? A lot of you saw that if I just add all those numbers in there and divide by 16, that's the number of outcomes there, 16. Or I could do, I have a 1 out of 16 chance of getting a 2, 2 out of 16 of getting a 3, and so forth. I'll still get 80 divided by 16, which is 5. All right, I believe your quiz is going to have 7 questions total. All right. There's a 20% chance of rain on Monday, a 40% chance of rain on Tuesday, 25% chance of rain on Wednesday. If it rains at all, a high school baseball game will get canceled. What is the probability that you will get to play on exactly 2 of these days? So Stan wants to say hi to the pin right there. How we going, Stan? All right. Anyway, the probability that x equals 2 is the following. So the probability that you play is 1 minus the probability that it rains. It's the complement of it raining. So you could play the game. So it doesn't rain, it does rain. It doesn't, nope, Stan wants that pen. Stan, I got to use that pen, buddy. It doesn't rain, nope. All right, Stan, pen's all yours, buddy. It doesn't rain, it does rain, it doesn't rain. And then finally, it does rain, it doesn't rain, it doesn't rain. All right, add them all up, and you get your answer. Right, buddy? All right. What is the probability that you get to play on all 3 of these days? So 3 straight days of it not raining. That's your answer. What is the probability that you will not get to play? So it rains every single day. What's the probability that you get to play on at least 1 of the 3 days? That's just the complement. It's 1 minus the probability that you don't get to play any of the days. Stan's having a good time with that pen. All right, this video is going to become too long, buddy, because it's going to be all about you. All right. Anyway, what's the probability that you get to play on at least 2 of these days? So that's the probability that you play exactly 2 days, probability you play exactly 3 days. And from earlier, we have that number right there, 0.45. And then that number right there, let's see, 31, or 0.315. All right. Number 3, you're an 85% free throw shooter and will attempt 2 shots. What's the probability you make them both? Make. There's your answer. What's the probability you make exactly 1? You can either miss or make. Add them up. What's the probability you make at least 1? Well, that's just either you make 1 or 2, or you do 1 minus the probability of making 0. Normally, you would want to do the complement, but you already have a probability of making exactly 1, probability of making 2, so just add them up. Your 76% free throw shooter is going to shoot 3 free throws. You make all 3. Make. That probability. What's the probability you make at least 2 of them? Well, that's the chance you make all 3, which we have, or the probability plus the probability that you make 2. You can make, miss, make. All right? Add those up. That's how you get 0.417. add that to the probability you make all three, and that answer 0.856. Remember, probability is a number between 0 and 1. Don't give me the percent, give me the probability. What is the probability you make at least one of the three? So that's a great complement question. It's just 1 minus the probability you make is 0. So you miss. About a 1% chance of missing them all. 1 minus that, about a 98.62% chance, or a probability of 0.9862. All right, moving on. Stan, you want to announce our sponsors, buddy? We'd like to thank the great Chinatown, Tazo Zen Tea, Coffee Espresso. What else, buddy? You're forgetting Caldy Coffee. Mention them. Laura Bar, Cliff Bar. Stan just wants to thank the Pen, Uniball. That's his primary sponsor. All right. Calc 2 at a certain university reported the following grades from their fall 2016 sections. 11% got an A, 26% got a B, and so forth. Anyway, assuming the normal 4, 3, 2, 1, 0 scale, 4 points for an A, 3 for a B, 2 for a C, and so forth. Find the overall Calc 2 GPA. All right, so it's just 4 times 0.11, 3 times 0.26, and then add that all up. Yeah, not great. That's solid C average right there. Spell checking software catches non-word errors that result in a string of letters that is not a word, as when, thus, type is that. Anyway, got a 250-word essay with no spell check. X is the number of non-word errors. Notice 0, 1, 2, 3, 4 or more. Those are all countable. All right, when I make an error, I make 5 errors. I make 6. I don't make 2.75. I don't make 3.13 errors. That makes it a discrete random variable. All right, countable, whole numbers, those variables. Right, the event at least one non-word error. That means X is greater than or equal to 1, and that probability is that plus that plus that plus that, or 1 minus what I don't want, making 0 errors. Describe the event. X is less than or equal to 2 in words. That means no more than 2 non-word errors. So that's 2 or fewer non-word errors. What is the probability that X is less than or equal to 2? I could do that plus that plus that. What is the probability that X is less than 2? That means 0 or 1, not 2. So that's why it is 0.41. All right. Choose at random a young adult, age 23 through 26. Ask their age and where they live. Here's a probability model for the 12 possible answers. What is the probability that the person is a 25-year-old who owns their home? Right there, that entry. What is the probability that they are 26? Add up that column. What is the probability that they live with their parents? That. Add it all up. What is the probability that the person chosen doesn't own their own home? So it's basically the complement of this. You could either add up the 8 entries here, or you can do 1 minus the people that own a home. So 1 minus 0.34 as well. So living with parents and owning a home has the same probability. That is just a coincidence there. All right, so basically we're adding up who owns a home, 34% is population, and we're doing 1 minus 0.34. What is the probability that the person chosen is over the age of 24? That means they're 25 or 26. So that plus that. All right. What is the probability that the person chosen is 26 years old or lives in an apartment, or both? So what we're really doing is we're taking that column and adding it to that row. But I notice when I do this plus this, I'm going to overcount that intersection. I'm going to overcount the 26-year-old who lives in an apartment. So that's why I need to subtract that 0.05. So I add up this column and I add up that row, but I subtract that 0.05 that I counted twice. All right, that's a big idea we'll continue to talk about the rest of this year. 0.49 is the answer. And lastly, folks, my favorite question here If I have 3 races on my schedule for the upcoming month and I have a 45% chance of winning the first race, a 30% chance of winning the second race, and a 35% chance of winning the third race, what's the probability that I come up goose egg? I don't win any of them, so it's the complement. It's the percent chance I have losing each race multiplied by each other. What's the probability that I win at least one? What's the complement of that? So it's 1 minus the probability I win 0. What's the probability I win at least 2 of these races? So I need to win 2 or win them all. The probability that I win them all is quite small. I could win, win, lose. I could win, lose, win. I could lose, win, win. Add those up and add it to the probability I win all 3. That's the probability I win at least 2. Find the expected value for the number of wins that I should have. So I need to know the probability of me winning 0, which I know, the probability of me winning 2, and the probability of me winning exactly 3. I just need that probability. I need to know them all individually. So the probability that I win 1 is I could win, lose, lose. I could lose, win, lose, or I could lose, lose, win. Add those up. The probability I win exactly 1 is that. So to find the expected number of wins, you take how many wins and multiply it by its probability, plus how many wins multiplied by its probability, plus how many wins multiplied by its probability, plus how many wins multiplied by its probability. So 1.1 races I would be expected to win there. All right, folks, that is your quiz review video. Again, spread the word. Your quiz is going to be now on Tuesday. You have an in-class homework that will serve as another really good quiz review. You can use your notes. You can use this on it. So we should be ready to dominate on Tuesday. 2 big grades coming early next week with your 25-point in-class homework Monday and your 50-point quiz on Tuesday. This is Yak Mac Videos signing out.